Hey folks, I'm Attacus, and today I am going to tell you a bit about how hard it is to disappear completely from machine eyes while you're going about the world, being an active human, and why you might want to do such a thing in the first place. Tracking people when they're walking around the real world is getting more and more dependent on facial detection and facial recognition. So if you want to be invisible to cameras, learning how that these things are used is the first step to finding out how to stop them being used on you without your consent. So that's what we're going to talk about. This is the introductory credits for the American TV series Person of Interest. There's a whole bunch of high-tech face detecting stuff going on here. Emotions and yeah, cool. All right. This is actually what's going on in the world. Some of you may have seen this. This was September last year, this video of traffic surveillance cameras at a Chinese intersection turned up online. And it's really easy to be skeptical about the things that you see online, but this is actually real software running on a live system. This is 100% Snopes verified, whatever. And this is a better version with sample footage that they've got, and this is in English this time. It's probably too small to read anyway, but this is showing you really basic stuff, you know, like what am I looking at? Is this a car? Is it a bicycle? Is it a truck? And then they are also tracking what color the car is, what color the vehicle is, the paths that people are taking as they walk or as they cycle. They're trying to identify what they think is a person's gender and their approximate age, and also you can see they're trying to identify the kinds of things that people are wearing. There's some trousers, shirt, that kind of thing. And this makes it easy to track people, even in a country like China where it's got a population of over 1 billion people. You see the snapshots on the side of the screen being taken and stored as soon as they appear. SenseTime, which is the company that makes the Sense Video software, have another product called Sense Face, which does exactly what it says on the tin. Picks up live streams from static sources like escalators, train station ticket barriers, all kinds of things, and it matches the features from those people to information that the company or the government using it has on file. And the Chinese government requires an ID card for all citizens over the age of 18, so they have all that info already. And you'll be able to see these time-stamped images being captured again here. Then they're matching it with people. But if you're thinking, okay, this is fine, and you're not surprised that this happens in a country like China because Chinese privacy laws are different to what we have in Australia, you may be interested in this. This is the maintenance interface of an advertising screen at a Westfield shopping centre in Belconnen in Canberra. This was taken in October last year. You can see it there detecting the two faces of the people in front of it. Is there anyone here who did not know before this talk that shopping mall advertising screens do this? Yeah. They pretty much all do. So Westfield detects what they think is your age, your gender, your mood, and they correlate this data with your smartphone pinging off their nice convenient Wi-Fi routers all around their malls. A spokesperson for Westfield said that they do this to connect customers with retailers in a more meaningful way. I have no idea what that means. But I do know that they use this data to track pedestrian patterns in their malls and to work out who's going where and what shops they're walking past, where they can place relevant advertising. They do all of this without your consent. You set foot in a mall, this will happen to you. The reason why Westfield thinks it's okay that they've rolled out this tech to all of their malls is a pretty important one. It's the difference between facial recognition and facial detection. Facial detection allows the system to detect when it thinks it is seeing a human face. Facial recognition means that a system can detect when it is seeing a specific human face, and it will likely connect the information about that human face to their real identities and other information about them. So Westfield and things like Sense Video, that's detection. They don't connect it to personal data. This is why Westfield doesn't need consent to do this. And the law backs them up on it. So the Australian Privacy Act of 1988 only regulates the collection of personal and sensitive information. This is things like names and addresses and medical histories. And Westfield doesn't need consent for anything else because it's not legally personal, which is completely ridiculous, but these laws are out of date like a lot of laws, because your face is pretty personal. It's in public all the time. It identifies you. In some cases, it can unlock your phone. But it's cool because it could become legal to do a lot more than this pretty soon anyway. So there's a bill being currently tossed around Parliament right now, this Identity Matching Services Bill of 2018. This is to draw together a database of faces from passports, driver's licenses, criminal records, immigration data, and other documents held by federal and state governments in Australia, and then to match those with information about our identities. And they will give Peter Dutton's Home Office, Office of Home Affairs, access to the whole capability. And they actually literally call it the capability with like a capital C, like they're a James Bond villain or something. That's what it's called. So this bill suggests that they want this capability for the following highly specific purposes: preventing identity crime, general law enforcement, national security, protective security, community safety, road safety, and identity verification. But it's pretty easy for Dutton not to be worried because facial recognition doesn't work on potatoes. And full-blown recognition capability might not be too much of a problem for Westfield soon anyway, because the Attorney General's Department's been considering selling access to this database of faces and info to private companies like Westfield as well. And a few weeks ago, a New Zealand supermarket chain also got a lot of press when it came out that they were using face recognition detection in their stores to try and detect shoplifters. And this only came out because they used this tech to apprehend the guy in a New World supermarket, and it turned out that he wasn't actually a shoplifter and not the person that they were after. Yay for cutting-edge technology. So, if you don't like the kind of facial detection stuff that goes on in public places and you want to opt out, but you still like shopping malls and walking on public streets, what do you do about it? Firstly, we have to understand how facial recognition works. There are 3 steps to this process. There's detection, face print creation, and then verification or identification. Traditional computer vision facial detection is all about the patterns. This is light and dark maps, the pattern of eyes, nose, and mouth on your face. This is an example of one of the oldest ways to do this. This is called the Viola-Jones Object Detection Framework. So it detects patterns of light and dark relative to the patterns next to them, and it refines its model over a few iterations. It's pretty crude pattern matching, and it needs a full frontal image of a face in order for it to work. But when it does work, it works pretty well. This is what most phone cameras will use to detect faces and put a box around them when you're trying to take a picture of somebody. It's cheap, it doesn't take much processing power. So how do you get a more accurate map of this face from when it isn't just front on ideal conditions looking straight at you? You create a mesh. This is the distance between the eyes, the width of the nose, the depth of the eye sockets, the shape of the cheekbones, length of the jawline, all of that kind of stuff. So this model is trained on lots of different photographs of people and kind of averaged out. And then this average model is placed over your face, which your phone has already detected. And the dot points are adjusted to fit the edges and the light and dark patterns of your face. And this model is refined by relating the dots to one another. This creates a mesh of your face that can track you as you tilt and you move. And there are some newer methods. This is what the iPhone's True Depth camera sees. This is just one frame. The iPhone projects an array of 30,000 infrared dots over your face to get a real-time sense of depth. And as I said, this is just one frame of data from those sensors. It takes many frames of data in real time, and then it compares them to each other to get a 3D map of your face. That's how the iPhone does it. So once we have a map of the face, however we do that, we can then try to recognize it. Recognition connects all of this info that we've just talked about with other data that the system already has about you. And in the case of the iPhone Face ID, you have to register your face first, and then it stores that information to compare new data against, which is why when you want to unlock your phone, and you've already set up that face print, and then you shave or something, may not work the second time around. Or you can have a mesh pattern compared to other mesh patterns in a different database, like a government database. That's another way of identifying and recognizing someone. Some recognition approaches are a bit different. Some of the earlier steps might have been skipped in favor of a different machine learning approach that happens after the face is detected. For example, Facebook has an algorithm. Facebook's algorithm is called deep face, which is great. This is used to auto-tag you and your friends in images, which is approximately 97% accurate. So the facial recognition system that I've set up for you, which is here, and we're going to use it after I'm done talking, is it uses a pre-trained deep convolutional neural network to do the detecting and the recognizing of the face. The one I've set up runs like this. It will take still photographs of people's faces, and it'll do a bit of mesh creation and skew them until the system has some kind of average, like what they've done to this picture of Will Ferrell. And then the neural network takes 128 separate measurements of the face. And you might be asking what these measurements correspond to. We don't actually know. The neural network kind of decides for itself what it wants to measure, however it does that. And then whatever happens, it comes up with these 128 points, which seems safe and not at all weird to let systems like this decide the legal fate of human beings, but whatever. Anyway, these measurements are unique enough to be used to identify people when the camera sees them again, because the network can run the same calculations and then cross-correlate with things that's already got stored, and that will be how it identifies you. So how do we mess with these things? This depends on whether you want to mess with facial detection, stop it at its source so that they don't even know a person is there, or face print creation, so it doesn't match the face print that you have right now with the face print that you have in a few seconds or a few minutes, or facial recognition, so it will stop them from recognizing that this is you specifically. And what I'm talking about isn't how to get facial recognition software to make it think that you are someone else, because that's a whole different game, which is more about security, and this is kind of more about privacy. I'm also not going to talk about eye scanning or gait analysis or any of the other things that are used to track people, because these are whole separate fields of study and I only have an hour. Anyway, in terms of faces, here are some things that people are already trying. And these things will work for some kinds of facial detection software or different stages of the facial detection recognition cycle, but it may not stop everything. Obscuring the whole face, or the majority of the face, using a mask or a balaclava. This is a very traditional technique for trying to stop yourself from being identified. It goes back about as far as humanity, favored by hackers in stock photos, good stuff. Obscuring the eyes. So your eyes and the bridge of your nose provide a huge data point in most traditional face maps. There's a lot going on in this particular area that's unique to you. Sunglasses cover these things. They make it hard to identify you. It may not fool facial detection, but it may fool the recognition part. It really depends on the software that's being used. Another thing, you can make weird faces. This actually does work on some things. Some software cannot reasonably recognize you when you aren't using a neutral expression. Passport photos and airport smart gates are in this category. When I've come off a long flight and I'm really tired, quite often it will take a couple of goes. At this point, I have to talk about the work of Adam Harvey. He's an artist who's based in Berlin. He does a lot of research work and projects around facial detection and surveillance. And he's most known for his CV Dazzle work, which is a computer vision attempt at dazzle camouflage. So dazzle camouflage, brief history, was used on ships in World War I. It was not intended to conceal the ships or make them invisible. It was supposed to make it difficult to estimate things about the ship, like how fast it was going or how far away it was from you, which way it was facing. That way, it was supposed to make the ships harder to fire at and harder to predict where they were going to be next. So if you're an enemy looking at the ship, you can't make assumptions about what it's going to do or where it's going to be. So it did this, like you see here, using huge blocks of color in irregular patterns on the ships to break up their outlines and their features so that they were harder to see properly. So in the same way, CV Dazzle, which is this stuff, will not make you invisible. To other human beings, it will make you look like you're really into Neuromancer cosplay, which is fine if you are. But to computers, it will make it a lot harder for the older and more common computer vision algorithms to recognize your face, because it breaks up a lot of the outlines that algorithms like the Viola-Jones detection framework are designed to detect. Mostly, it, as you can see here, messes with these patterns of light and dark. And Harvey has experimented with a lot of different CV dazzle looks over time. You can see more of them here, and more of them at his website, which is cvdazzle.com. He's got a whole gallery, it's really good. Also by Adam Harvey, there's this. This is the Hyperface project. This aims to saturate some kinds of facial recognition algorithms with a bunch of patterns that it wants to interpret as faces, and to stop it recognizing actual faces. So you could, and Adam Harvey has, made shirts and clothing printed with this, and if you wear that walking down the street, some computers will freak out. So will some people. This is the Stealthware project. This is also Adam Harvey. He's created a fabric. This is actually silver-plated and thermally reflective, so it stops the thermal signature of the person wearing it from being read by a long-range infrared camera. And this one stops the detection of faces, again, mostly by covering them, but it can also stop the detection of people more generally. He also sells this mirror. Okay, this is not Adam Harvey. This is a guy called Saif Siddiqui who's done this one. This is the paparazzi scarf. This scarf, they say Siddiqui was inspired to make this after a bicycle reflector ruined a photograph of his when he was using flash, because it reflected all the light right at him, and he thought, okay, that's a good way of stopping someone taking a picture of you. So it's pretty effective. Apparently even Paris Hilton has one. And the scarf in this picture will cost, it costs I think about 630 Australian dollars, which is why Paris Hilton gets to have one and you don't. But for everyday people who don't have $630 to drop on like one scarf, there are reflecticals, which are along the same lines as the paparazzi scarf, but for your face. This was a Kickstarter project. They are sunglasses with reflectors on the front of them, and they work a little bit like this, with visible light and with infrared light as well. They come in different colors too. Okay, so this is stuff that people are already trying and have been doing for a few years. And I want to emphasize that not much of this stuff is going to work on humans. They won't stop humans from seeing that you're there. You will be visible to other people. You can't use these things to try and make mischief in broad daylight, but computers may not be able to detect you or recognize you, which is much better for your privacy in some ways. There are also some emerging methods for thinking about how we are going to work around newer detection algorithms, but they're not very well formulated yet. A lot of them are still experimental, or they're papers that came out this year or late last year, so they're still in the early stages. But I'm hoping today to get you thinking about some new counter-surveillance methods as well. Hopefully something in this will spark an idea for someone here, and we'll see what we can do with that. Right now, the most effective way to not be correctly identified by facial recognition algorithms is not to be a white guy. Because a lot of these algorithms were built in California by primarily Caucasian men and trained on data sets full of pictures of Caucasian men. So which means they're super good at recognizing Caucasian men for some reason. This isn't necessarily good news, though, if your skin is a different color, because it means that you are more likely to be incorrectly identified by buzzword technology. And in criminal investigations, where you've already got a lot of bias at play, this can be very, very bad. However, you are less likely to be detected if you're not a white guy. Another option is to be a baby or a child, because most neural networks are not trained on pictures of kids' faces. And the proportion of young human faces are actually really, really different to adult human faces. So most systems aren't actually expecting them to be human faces. So you two are set. Something I haven't seen done for facial recognition just yet is stickers. So a research team at Google discovered that what basically amounts to vaporwave stickers will completely mess with the neural network, which is trying to detect things in a photo. In this case, the presence of the sticker makes the neural network think that this banana is actually a toaster. I don't know how it decided that, but it did. I haven't seen this kind of thing tried with human faces yet, but it's probably worth a shot. And in other ideas, there's this paper which was published in March. It showed that beaming patterns of infrared light into your face, and that's not a visible human spectrum, so it won't bother you. But beaming that light into your face in different ways, it can make facial recognition algorithms think that you are someone else. So these researchers here successfully got one of their team members to be recognized as Moby using this method. And the way they did this is they've got this small array of infrared lights mounted on the brim of a cap, and then they program those to shine on the face of the person wearing the hat in different patterns. And that has some pretty interesting effects. Again, this only came out in March, so it's still pretty experimental at this point. But I've brought along a bunch of stuff, which will be over here in just a second, to help you try these things out for yourself if you feel so inclined, and come up with new ways to full computer detection, or computer vision facial detection, and possibly recognition. So it's all going to be just over here on this table, and when I'm done here, which will be soon, I promise, feel free to go and try it out, and I'll hang around and ask questions. So what this is, a bit more information. I've set up a station which runs a basic implementation of the Python face recognition library, because Python is magic, and that's about all you need to make this work. So you can play around with some of the disguises. I've brought some wigs and some beards and some masks and some face paint and some reflective tape and a few things. You can play around with what I'm setting up for you. You can play around with the apps that you have on your phone, like Snapchat, your camera app, whatever else you have. I'd like you to enjoy, have fun, and play with that. The stuff that's running on my machine is just running locally. That machine is not connected to the internet. That information is not going to be stored anywhere in case anybody is concerned about that. But the camera will be pointing this way, so if you don't want to be on it, I will give you a bit of time to not be in this part of the room. I know you can't read this, but that's fine. I'll go over this in a second. But just to give you some inspiration before you start playing, on the CV Dazzle website, Adam Harvey has provided some style tips that might help you. And they basically amount to this. So if you've got makeup, avoid enhancers, because the whole point of them is to amplify key facial features. They make your face easier to detect. So instead of that, you can apply makeup that contrasts with your skin tone in unusual tones and directions, all of that. Light colors on dark skin, dark colors on light skin, all of that. The nose bridge, again, as I said earlier, there's a lot of information in this area. This is the region where the eyes and the nose and the forehead all intersect. Some facial recognition algorithms go as far as detecting the shape of your tear ducts as a unique identifier for you. So you can obscure that. That's a pretty good way of stopping yourself being recognized as you. Eyes, overall, as well, just obscure them. Masks are really effective and also pretty illegal in most places. So that's useful, but probably not practical. And your head also. Obscuring the shape of your head, you're wearing a funny hat or something, this can improve your ability to block face detection because it's expecting something vaguely like that. And also asymmetry. So facial recognition algorithms expect some kind of vague symmetry between the left and right sides of your face. So if you develop an asymmetrical look, you might decrease your probability of being detected. Finally, one of the last things that you can do to mess with facial recognition is to stop our government from making it more into a law. So like I said earlier, the Identity Matching Services Bill is currently being discussed in Parliament. So it's a really good time to start making some noise about it, speaking to your representatives, talking to other people to let them know how this stuff works and how it can get used and how it is used. Because this stuff doesn't have to be inevitable or acceptable in public spaces just because. And with that, thank you for coming, and let's have some fun playing with that stuff.